coffee mug here. It says, I am a ray of fucking sunshine. So without further ado, let's begin. You'll probably see on the screen that the only thing showing right now is the window. So I'm on a laptop, and we're gonna put the volume down a little. Check it out, DMCA and copyright free music for Twitch streamers. That's me. I like my lo-fi beats. Have it be quiet because we're gonna watch some video and this is gonna be background music, but also got a drink. This is not sponsored, by the way. Got organic nutrition. Yep. Vegan protein drink. Thanks to Amazon Fresh. You can't see it, but right over there, I'm using a MacBook as a coaster. Okay, because we don't stan MacBooks in this house. I did get the MacBook for the lulz because I'm a computer engineering student and I've always been a Windows girl. I think my first operating system was Windows 95. I definitely have more distinct memories of Windows 98 and playing Wolfenstein and the 3D wallpaper, 3D screensaver, which was the maze. That was pretty cool. Let's just clean up the desk a little bit. Gatorade. I also like Gatorade, not sponsored, but I would shill Gatorade. I think it's better than G Fuel, probably. I assume it has less sugar. How much sugar do we have here? It's a lot of sugar, I guess. But, I have someone in the chat. That's Evan. I don't know if I'm allowed to say your name. Metafish. Hi. Alright. And here's my paper book. Let's see, we have some to-do lists. Alright. Cool. Cool. So before you came in, I was talking about a little of the specifics of the new streaming setup I have. It's at a new desk, and I'm doing it newly on my ThinkPad, which is the superior machine to my MacBook, which is a coaster now. And you can rewind if you want to hear about it. But I'm moving forward onto my studies, onto electrical engineering, which we're doing circuits 2, the 2000 series. I finished all my circuits 1, and I believe I'm going to be working in multisim or watching some videos. Either way, I think you'll learn something if you stick around. Alright, so here's my system. I'm just in 2 classes for the summer. And I hate this system. I used to have a different one. It was called Blackboard, and it was just far superior. Okay, cool. Thanks for popping by. Oh. Let's see, I think... Do you use a Windows or a Mac, Evan? Aw, thanks. Okay, if you use a Windows machine, you should check out this program called Always on Top. I think I have to re-download it. Second. Okay, so Always on Top. Here it is. So pretty much like I was switching to my Chrome Windows, my internet out of OBS, and I lost the chat pop-up, but I think I should be able to fix that with this tool. Here it is, Always on Top. I'm downloading it. Unzip it. Even if you don't use it for streaming, it's good for just like random things. Like, oh, you know, it's great for if you're using the Notes program or Notepad. You can, it's like Control Spacebar, and then the Notepad will stay at the top of your screen. Yeah, 7-zip is superior to WinZip also. Alright. Now, you probably can't see what I'm doing right now with the Always on Top downloading, because I'm just sharing my internet window, not my desktop. Okay, so now I should be able to read the chat. Yes, okay, it worked. VLC has it built in. Yes, exactly. Yeah, usually a 2-monitor setup is the best for streaming, but I like moved my living situation, and having a 2-monitor setup is like a little difficult for me right now, but now I have a comfortable thing. And also sharing the window is nice if you have a single monitor, because that way if I want to like check my email, I can open up a separate instance of Chrome as opposed to a tab, and that way I can like check my like my bank statements or like any private stuff, and it's not going to be caught in the stream. Okay, so here we go. Yeah. I'm glad. I'm trying to educate the people while educating myself. Learning is fun. Alright, I don't know which class I'm going to do first. Yeah, these are the videos my professor was talking about. Solutions? Is this? Oh, of course the professor's playing me. Playing me with the solutions. I wish they were there. circuit, 2100. Yeah. I gotta get the syllabus for this class. Don't email my professor. This semester I'm going to be designing and analyzing practical AC circuits, network theorems, phasors, equivalent circuits, sinusoidal sources, steady state analysis, all good stuff. And got my handy dandy my physics formula sheet, which has like some electrical stuff in there, so I'm going to be making use of this. And put that over there. Probably because I'm talking super quietly, but also the music might be kind of loud. There we go. Can you hear the music at all? I might have put it too quiet. Because I can hear it a little bit. Okay. Yeah. So I think other streamers have done this kind of stuff, but not to the level I'm doing it. I'm definitely going to be sharing all my course content, and if I do this every time I study, it's probably similar to like OpenCourseWare. Let's see. So, this is the okay. Yep. Writing. Today's date is 5/30/21, and the course number is EET2100. Okay. And this is circuit 2 homework. Oh, this pencil sucks. What are you streaming, Evan? What, like, did you do the Pete Dilworth one already? I think you're gone. I don't know if you heard my question. Let's see. Homework. Video notes. Oh yeah, okay, so that already happened. I gotta watch it. Is it still on your channel, your Twitch channel, or do you have it on a YouTube? Because I'm gonna upload the stream to a new YouTube channel I have. It's just... Okay, cool. Yeah, I created a new channel just for my live streams. So those will be like this one's probably going for 2 hours.
Sorry, I didn't understand.
Oh my god, my Google Home is listening. Oh, hey, I heard that Amazon made a deal with the NHS to acquire patient medical records. So that's going to be fun. They're going to corporatize your probably like physical and mental health documentation, monetize it. Everybody is a product all the time. I'm gonna definitely check out your video after I check out my professor's video. These videos. Test 1, July 10th. Note. First quiz is July. Oh, that's weird. It's available until July 10th, but it's due June 20th, so that kind of implies you can be late taking the test, possibly. I say that is a little bit sus. This quiz is an imposter. Okay. First quiz is due June 20th. Really just me and 2 other kids. Oh, my name was on that shit. Oops. I'm really bad at keeping my name anonymous on the internet. Hopefully I don't get any more death threats. Have you gotten any of those, Evan? Alright, I'm gonna make this regular volume because we're gonna be watching this together. Actually, wait, first I'm gonna print it out so I can note down which ones that I've watched. 36. That's not too bad. Oh. Got something going on with the printer. Document waiting. It's not waiting for me. Printer properties. Oh, my always on top failed me. I used to have a thing that would tell me... Alright, yeah, no worries. Actually gonna check something on my phone real quick. Okay. So, yeah, I'm just gonna be saying that I'm printing out. I printed out the show. I printed out the YouTube video list so that as I watch them, I can cross off which ones that I've seen. It's going to be very handy. Okay. Thank you. I had some bad semesters, but I'm determined to be a good student this semester. Summer of 2019, I took way too many classes, and I just had the world's most ridiculous burnout. Made me question a lot about my life and choices, and no matter how much I thought about it, I thought nothing else I really want to do besides be a computer engineer and make cool shit. Learn about circuits. You bet. Forgive me for staring at my phone. I'm trying to figure out something about my stream setup. Ah, there we go. Okay, does that... Alright. Yeah, I'm good. I'm good. Here we go.
So what is j squared? It's -1. What is j cubed? It's j squared times j. J squared is -1 times j. That's -j. What is j to the 4th? It's j squared times j squared. -1 times a -1, which is what? 1. What's j to the 7th, for example? Well, j to the 7, you can go, that's j to the 4th times j cubed. What's j to the 4th? 1 times, what's j cubed? -j, so the result is -j. What is j to the 10th?
This is actually the professor of my class.
It's j to the 4th times j to the 4th times j squared.
This is not a random YouTube video. That is my professor. That is pretty cool and crazy. I actually did have a professor way before the pandemic I think he was my pre-calculus teacher, and he had a YouTube video. He had a YouTube channel and YouTube video for the supplemental education. Whenever I think of that professor, I always think about how, like, one time he emailed me and said, like, my wife just had a baby. And I'm like, oh, that's an amazing time to be, like, teaching through the internet. So I don't know. Life is funny. Let's see. So this was uploaded in 2015. It's got some comments on it. A lot of like seemingly possibly Islamic Muslim people. And then this guy, am I being detained? Anyone else smoking a J while watching? Oh gosh. There you go. Alright.
J to the fourth is 1 times j squared, which is negative 1. That's a minus 1. So you can find any j to the power. The best way to look at it, look at it, j here. J squared, which is negative 1. J cubed, which is negative j. And j to the fourth, which is 1. So when somebody asks you what's j to the 7th, start from here. Go 1, 2, 3, 4, 5, 6, 7. That's a negative j. What is j to the 10th? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's j squared, which is minus 1. What's j to the 15? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's a negative j. Why? Because every 4 j's repeats itself. So what you can do, you can take the 15 and divide it by 4, which is what? 3. 3 times 4 is 12. Remainder is what? 3. So 3 sets of j to the 4th times j to the 3rd. Well, every one of these is 1. 1 times 1 times 1, which is 1. So you end up with j to the 3rd, which is what? Negative j. What is j to the 5001? I'm not going to go 1, 2, 3, 4, 5, 6, 7. I go 5001 divided by 4. 1. 1 times 4 is 4. Bring the 0 down. 10 by 4 is 2. 2 times 4 is what? 8. 20. 20 by 4 is 5. 5 times 4 is what? 20. Bring the 1 down. 1 by 4 is 0. 0 times 4 is 0. The remainder is 1. So it's going to be j to the 4th. How many sets of these we have? We have 1,250 of them. 1,250 sets of j to the 4th. And there's one more j left at the end, on the bottom. So this is 1. 1 to any power is 1. That's a j, which is what? Square root of minus 1. Or just j. So you can find j to any power by doing that quick math. Every 4 of them, you get a 1. And 1 times 1 times 1 times 1, 1,250 times is not going to change it. Now, when we look at complex numbers, here we go.
Screen's blank for some reason.
Oh, unplugged here because I moved that thing. Hope still recording. Complex numbers. A complex number has a real portion and an imaginary portion. You know, when you look at the rectangular coordinates, this is the real portion of it. This is the imaginary portion of it. Or I am imaginary. So a complex number will look, it has a format A plus JB. So for example, you might have a complex number 3 plus 4J. If you were to graph that, what would the graph of that look like? It has 3 values in the real direction and 4 in the imaginary. So this vector will look like this. That's 3 plus 4J. It has 3 units in the real direction and 4 units in the imaginary direction. Now the question is, how do we deal with complex numbers? How do we add them? How do we subtract them? How do we multiply them? How do we divide them? So if you want to add complex numbers, A plus JB, that's a complex number, and you want to add to it C plus JD. To add them, you add the real portion to the real portion, and the imaginary portion to the imaginary portion. And that's the same for subtractions. If you were to subtract them, we do the same thing. The minus sign says if you're adding or subtracting, it's the same thing. So if I have 5 plus 3J, and I want to add to it 4 plus 2J, I'll add the real to the real. 5 plus 4, which is what? 9. 3 plus 2, which is what? 5J. Straightforward. Just like if you treat J as X. If you're adding 5 plus 3X plus 4 plus 2X, don't you add like terms? The ones with X together, the one without X together? Well, that's the same thing. And the same thing if you're subtracting. 6 minus 5J minus 4 minus 3J. That'll be 6 minus 4. That's the real portion, which is what? 6 minus 4? 2. The imaginary one will be negative 5 minus a negative 3.
Negative 2J.
Negative 2J. So that's addition, subtraction. What about multiplications? Let's say I want to multiply. I'll go like this. I want to multiply 5 plus 3J times 2 minus 4J. How would you multiply if this was 5 plus 3x times 2 minus 4x? What method would you use? FOIL. Exactly. We're going to use the FOIL method.
First, inner, outer, last.
In the FOIL, it says first, outside,
Oops. First,
inside,
outer, inner, last.
and last.
It says last.
So that's the method I'm going to use, the FOIL method. 5 times 2, 10. Now let's go to the O, minus what? 20J. Inside, 6J. Plus times a minus, it's minus what? 12J squared. Wait a minute. What was J squared? Negative 1. So what is minus 12J squared becomes? That's a negative 12 times a minus 1, which is what? Positive 12. J squared is minus 1. So now you take like terms, you put them together. You have 10 plus the 12, which is what? 22. Negative 20 plus 6, which is what? Negative 14J. So it's nothing more than the FOIL method. This used to be really important for us in circuit. Now we all have graphing calculators that does all the stuff for us. I don't even have to do this by hand. The calculator does it for us, but we'll still practice it. Another multiplication. I can't use the FOIL method. I gotta use the distributive method here. Two j times j. It's 2j squared. And that'll be what? Minus 8j. Since j squared is minus 1, what's 2 times the minus 1? Negative 2 minus 8j.
Ooh, I'm starting to
Now,
memorize
how about
all
division? If you were to divide,
the mathematic concepts I used to struggle through, like what sign.
well, before I take it to division, let me just throw this problem and tell me what are you going to do. If you have 4 minus the square root of 5 divided by 3 plus the square root of 2, how would you simplify that?
Well, multiply by conjugate.
Yep, multiply by the conjugate, which is what?
3 minus 2.
Very good. 3 minus the square root of 2. You multiply the top and the bottom. Well, guess what? Since j is the square root of minus 1, we're going to use the same logic here. So if I have a complex number, which is 5, plus, let's say, 4j divided by 3 plus 2j, and I want to divide that, I need to multiply by, we call them complex conjugate, because these are complex numbers, and that's 3 minus 2j. We multiply by the complex conjugate. And when you multiply the top times the top,
Let's take a little
and the bottom
pause
times
to just confirm what is a complex conjugate. Damn, I don't get that one. Let's watch Khan Academy. Best site ever. But not that great for me to donate, because, yeah, I'm a poor student. I'm not preparing for a test.
Number 7 minus 5i. And what you're going to find in this video is finding the conjugate of a complex number is shockingly easy. It's really the same as this number. I should say be a little bit more particular. It has the same real part, so the conjugate of this is going to have the exact same real part, but its imaginary part is going to have the opposite sign. So instead of having a negative 5i, it will have a positive 5i. So that right there is the complex conjugate of 7 minus 5i. And sometimes the notation for doing that is you'll take 7 minus 5i. If you have 7 minus 5i, and you put a line over it like that, that means I want the conjugate of 7 minus 5i, and that will equal 7 plus 5i. Or sometimes someone will write, you'll see z is the variable that people often use for complex numbers. If z is 7 minus 5i, if z is 7 minus 5i, then they'll say the complex conjugate of z, and you put that line over the z, is going to be 7 plus 5i. Now you're probably saying, okay, fairly straightforward to find a conjugate of a complex number, but what is it good for? And the simplest reason, or the most basic place where this is useful, is when you multiply any complex number times its conjugate, you're going to get a real number. And I want to emphasize, this This right here is the conjugate. 7 plus 5i is the conjugate of 7 minus 5i. But 7 minus 5i is also the conjugate of 7 plus 5i for obvious reasons. If you started with this and you changed the sign of the imaginary part, you would get 7 minus 5i. They're conjugates of each other. But let me show you that when I multiply complex conjugates that I get a real number. So let's multiply 7 minus 5i times 7 plus 5i. And I will do that in blue. 7 minus 5i times 7 plus 5i. And remember, whenever you multiply these expressions, you really just have to multiply every term times each other. You could do the distributive property twice. You could do something like FOIL to remind yourself to multiply every part of this complex number times every part of this complex number. So let's just do it any which way. So you'd have 7 times 7, which is 49. 7 times 5i, which is 35i. Then you have negative 5i times 7, which is negative 35i. You can see the imaginary part is canceling out. Then you have negative 5i times positive 5i. Well, that's negative 25i squared. And negative 25i squared, remember, I squared is negative 1. So negative 25i squared, let me write this down. Negative 5i times 5i is negative 25 times I squared. I squared is negative 1. So negative 25 times negative 1 is positive 25. And these two guys over here cancel out, and we're just left with 49 plus 25. See, 50 plus 25 is 75. So this is just 74. So we are just left with the real number 74. Another way to do it, you don't even have to do all this distributive property. You might just recognize that this looks like this is something plus something times, or something minus something times that same something plus something. And we know this pattern from our early algebra, that a plus b times a minus b is equal to...
I'm putting a pause on that. I think we got the idea. Control-Shift-T. Okay, so... down in my notebook, I've already noted that the first quiz is due on June 20th. First quiz is due June 20th, and then watched complex numbers. Also have conjugates. Alright, I just texted my roommate with what my YouTube channel is, saying if she gets bored of her studies and wants to get even more bored, she can watch me.
At the bottom. Let's look at the top. 5 times 3 is 15. Minus 10j. Plus 3 times 4 is 12j. Minus 8j squared. Let me finish the top. This is actually plus 8 because j squared is minus 1. Minus 8 times the minus 1 is plus 8. 15 plus 8, 23 plus what? 2j. Let's look at the bottom. 3 times 3, which is what? 9. Minus 6j plus 6j minus 4j squared. These two will cancel each other out. The 6j and minus 6j. This is plus 4. 9 plus 4 is what? 13. So you can leave it like this, or you can write that 23 over 13 plus j 2 over 13. Doesn't really matter which way. So that's how we deal with complex numbers. Now, when I start talking about complex numbers, I began with this one. This picture, that's a complex number. Well, we can rewrite that instead of 3 plus 4j, we can figure the magnitude of this vector and the angle. Remember that from physics? It's a vector. You can find the length of this vector plus the angle, and you can write that what we call polar notation. So the first one is complex. Now let's talk about polar.
Oh, good. Polar numbers. Oh, hey! That's not... That was abrupt.
All right.
Professor Leonard. You're not my professor. Alright, I gotta get another one of the videos. Polar coordinates. I'm going to take a break in half an hour. So 2 o'clock I'll stop, which means I should get to so let's say 5. Okay.
Again, I'm going to give you a problem in rectangular and change it to phasor. We have 3 plus 4j. That's 3 in real, that's 4j in the imaginary portion. This is the real portion. This is the imaginary. So this we call vector A has a value 3 plus 4j. Now, if you don't want to do that in phasor, you can change it to what we call polar. I mean, in rectangular mode, you can change it to phasor mode or polar. Sometimes instead of phasor, we use polar, the same thing.
Oh. Note that down.
Polar, phasor. Our book, when we deal with sine, cosine, they call it phasor. In math, they don't deal with sine, cosine, just called polar coordinates. So to change it to polar, that means I need to know what the length of this vector and what that angle. Well, using what we know on trig, Pythagorean's theorem, we'll call this side C. Pythagorean says C squared equals what? A squared plus what? B squared. So to change a problem to polar, the magnitude of that is going to be, that's called the magnitude of A, is going to be the square root of what? The real portion squared, because A is the real portion, and B is what? The imaginary portion. So this will be the square root of 3 squared plus 4. I don't put 4j, just 4. We're talking about the value of it. So that's what? The square root of 25, which is plus or minus 5. In this case, it's the length of a vector, so it's plus 5. Now, how do you figure what the angle is? Theta. Theta here will be what? The inverse tangent of the side that's opposite, which is what? The imaginary over the real. The opposite over the adjacent. My opposite side is the imaginary side. My adjacent one is the real side. The inverse tangent. So theta will be the inverse tangent of 4 divided by 3. And if I go to my calculator, and it doesn't matter what mode you're in, you can be in degree mode, radian mode. So just make sure you write it that way.
Capacitor hair clips.
Inverse tangent of 4 divided by 3. And it's 53 degrees. So now this vector can be written in polar as 5 angle 53.1 degree.
I'm copywriting this.
Slash angle.
Let it
If you look at my calculator, the TI 89, or this is 86 actually, we have that mode on it. See it right there? Right over the comma. That little angle. I can write that 5 angle 53.1. I don't know if you can see it. Our calculator actually can add in polar, subtract in polar, multiply and divide. The 83 doesn't have that button on it, but you can get to polar by going to math mode. They have that polar and coordinates, or is it math? I think it's math and mode, one of them. So how do we add in polar? You can't really add in polar. That's the problem with them. Rectangular is beautiful to add in rectangular mode. Notice we just take the real to the real, the imaginary to the imaginary. You cannot add in polar. So if I want to add 5 angle 20, and I want to add to it 4 angle negative 30, add or subtract. I can't add them in polar. I got to convert them back to rectangular if I don't have one of those calculators. And this will be to convert to rectangular 5. And by the way, just think about this. This is what you have. There's your vector. Physics, think of physics. You have a vector 5 angle 20. And you have another angle 4 angle negative 30. How would you add them?
Add the component.
Yep, you find the x and y components for each one. And you add the x to the x, the y to the y. So you need to find the x and the y component. Well, what's the x component? Well, for this vector,
I'm not getting
the x component is going to be the cosine of 20, and the y component is what? The sine of 20. Remember that? So this would be 5 cosine 20 plus j, the y value, 5 sine 20. And the other one will be what? The x.
5 minutes in, and it's kind of confusing. What should I do? She is pretty. And electronics. She's subscribed. Way to go, Professor. Never seen this Professor Leonard before. It's all up there. We will say, hooray, another pretty woman in STEM.
Again, I'm going to give you a problem in rectangular and change it to phasor. We have 3 plus 4j. That's 3 in real, that's 4j in the imaginary portion.
Okay. I'm not sure if these are in order. Because this one is talking about polar coordinates with complex numbers, but I'm looking at the list and I see introduction to phasor, which is interchangeable with polar, is listed as number 4, and this is the number 2 video. Would have been nice. Would have been nice to have this in order, wouldn't it? Let's check it out. I feel like I'm doing something illegal. Okay. Let's, bam.
As I said, phasor is a nice way to solve a circuit problem that has a sine or cosine for a source there. So if my source is, for example, here we go, my source is a DC source, AC source, has some value, Vm cosine Wt. Well, if it's Wt, that means you can write that Vm cosine Wt plus, there is no phase shift, so it's really 0 phase shift. So in phasor, we take the source and we write that Vm angle 0.
So it's pointing 0 to the 0 power.
No, that's 0, angle 0. Not 0 to the 0. If your source, for example, is this one, let's say you have a current source like the previous example, and it was cosine WT, we found beta to be 30 degrees. Then in phasor we write that I sub m angle 30 degrees. So we just put the phase shift, the angle. What happens if your source is a sine instead of a cosine? Can you change a sine to a cosine? What is it?
You just add like a phase shift.
Which is how much the phase shift? Oh, it's 90 degrees. I forgot to get an eraser.
So instead of being 0, it would be VM 90 degrees?
Is it a plus 90 or a minus 90? Now think about it. Cosine WT, and the question, is it plus 90 degrees or minus 90 degrees? Well, let's think about it. What sine of 90 degrees? 1. If you make that a plus, right? If you make that a plus, what's cosine 90 degrees? If WT is 90, if you make it a 90, WT is 90 degrees. Let's say this value is 90 here. What is sine 90 degrees? 1. Well, if this is 90 and you put a plus, what's 90 plus 90?
180.
What's cosine 180? So it's not the same, right? But if you make it a minus now,
Then it makes it
what's 90 minus 90?
0.
0. What's cosine 0? 1, the same as this. So it's minus 90 degrees. So when you have a sine function, you can write that as Vm angle negative 90 degrees.
So like whenever we say like an angle with that angle symbol,
Yep.
do you assume there's a WT attached to that?
No, WT stays the same. Remember when you have a sine, the frequency doesn't change, it's going to be a phase shift? We're looking at that's the phase shift. So I don't even bring WT into the problem because it's going to be in the answer. So I avoid that, putting it complete. That's like, why waste my time when it's going to be there? So if I have a source here of Vm sine WT plus 40, I go, well, I can change the sine to cosine by subtracting 90 degrees, right? So this would be Vm cosine WT plus 40 minus 90, which is what, negative 50? So I can write that as Vm angle negative 50. So when I solve my problem, then when I change it back from phasor to time domain, I'm still going to leave the WT there. So I work it backward. So if my answer when I solve it, I'm just jumping here. If when I solve the problem, let's say I finish the whole problem, my answer, I started with the source, this source in my problem. 7 cosine 377t plus 15 degrees. Let's assume that's the case. So when I write that source, I would write that source at 7 angle 15. And remember what my procedure is. I said what this method is, we're going to take a problem that was in time domain, change it to phasor. I just changed that source from time to phasor. I'm going to solve it in phasor. And let's say when I solved it in phasor, my answer was the current I is 4 angle 30. Right? Now I need to change it back to time domain. So what is my answer is going to be in time domain? If my answer is 4 angle 30, then I know when I change it back to time domain is going to be 4 cosine the 377t plus the 30 degrees.
Would there be any reason why, besides putting the final answer in cosine, you wanted it in sine? Or, no?
Cosine sine is the same thing, just a shift. But because phasor goes from cosine to phasor directly, I always put in cosine. But if the angle like is minus 150, you can change it to a sine if you want to. Or subtract 90 degrees and put in sine. But that's changing it from time to phasor. This is back from phasor to time domain. Now, I didn't show you how to change, we just showed you how to change the source. But how do you change the capacitor? How do you change the inductor? How do you change the resistor? Convert them from time to phasor. So let's look at that. Here's the good news.
So what we just did was just change the
From time to phasor.
just a source to time.
Yep, just a source so far. Now, what about the resistor? What about the capacitor? What about the inductor? When you change them to phasor, the resistor stays the same. I'll jump to the inductor. The inductor value becomes J omega L. And the capacitor, 1 over J omega C. Now, if you have a J in the bottom of fraction, you can rationalize that. How do you rationalize it? You multiply the top and the bottom by J, which makes a negative J in the bottom, or J squared, which is a minus 1. So you end up with negative J over omega C. So mathematically, that's the same as this. And again, it came from this math. You say, I need to rationalize this. I'll multiply the top and the bottom by J. What's 1 times J? J. What's J times J? J squared WC. What's J squared equal to? Negative 1. Oh, that's J here. What's J divided by minus 1? Negative J over omega C. So a lot of times you see me write negative J over omega C instead of 1 over J omega C. It's the same thing. So let's take the problem we just did and see if we can solve it in phasor. Everything we learned before, remember Ohm's law, V equals I times R? That's still true here. In phasor, V equals, we use capital letters, I times R. Ohm's law doesn't change. Remember, some of the voltage in a closed loop is zero mesh and nodal analysis? They don't change either. Everything stays the same. So let's take that problem we just did a few minutes ago and do it again. Let's put some numbers in it. Instead of VM and all this, let's say we have, pick a value for the source. What do you want? 5 cosine what? Somebody pick a number. 10t, is that what we said? Or 7? Plus 7. There we go. Is a phase shift of 7 degrees. We have a resistor of 50 ohm. I'm just making things up. And we have an inductor, 3 Henry. First thing first, what is W here? 10. Very good. That's this number. Remember that solving in phasor, the first step is what? Convert from time. Let me go with that. Convert from time domain to phasor. Let's see. That source becomes 5 angle what? 7 degrees. The resistor does not change. And the inductor has a value of j omega L. I use boxes instead of drawing even pictures. J omega L, J 30, right? Let me use a box for the resistor even. I like boxes better than resistors. That's what my circuit is. I converted the source to phasor, the resistor to phasor, the inductor to phasor. And now we treat these, even the inductor, just a complex value, just like if it was a resistor. If I'm looking for the current here, these two we call them impedances now. That's an impedance. These two impedances are connected how? So if they were resistors in series, what would you do? Then we're going to do the same thing here. We're going to treat them just like if they were resistors, but they just have a funny number. 5 angle 7. The value here becomes 50 plus J30. Now let's solve it in phasor. How would you solve for the current here in phasor? If this was a voltage source and that's a resistor, what method would you use? Ohm's law. V equals I times R, or in this case, I times Z. Impedance. We use Z for impedance. They're not really resistors, it's an impedance, complex value. The voltage is 5 angle 7. The current I'm looking for, and the impedance for the circuit is what? 50 plus J30. Can we find I? 5 angle 7 over 50 plus J30. Where's my calculator? 5 angle 7 divided, my calculator can mix and match modes, thank goodness. 50, comma, 30. I don't know if I have to put J or not. I think I'm okay. And my calculator gave me an answer of 0.086 angle negative 23.9 degrees. Almost 24. I'll go 24 degrees. 23.96. What's the third step?
Put it back to time.
Change it back to time. See how quick? Now convert to phasor. It's not that difficult. Solve in phasor just like if it was simple resistors. Done, done, bum, bum. And now the next step is step number 3. Convert from phasor to time. We know the current in phasor is 0.086 angle negative 24 degrees. That becomes 0.86. We had a cosine in the problem. W was 10t, stays the same, but now I have a phase shift of negative 24 degrees. And we use lowercase because that's in time domain, that's in phasor. So that's how we approach these problems. Instead of solving them in time domain, it's a lot quicker and easier to solve them in phasor. Now let's take a bigger problem here.
If you had a current source instead of a voltage source, you
Same
would
thing.
get the same.
Same thing. Yep. Let me see if I can find a decent problem. I'm looking for one with numbers in it instead of. I'll go to the back of the book. I'll get a decent problem. Phasor is actually a technique we're going to learn to use to solve an RLC circuit or RLRC, but usually RLC because those are the ugly ones, when your source is a sine or a cosine function. If your source is not a sine or a cosine, this is not the method you want to use. And again, as I said before, the way the technique really works, we're going to take a problem in time domain, a circuit problem in time. We're going to convert that to complex. Then we're going to solve it in complex because it's much easier. And the last step, change it back to time domain. Convert to time. And again, the reason it is much, much easier when your source is a sine or cosine, when your source is sine / cosine, it is much easier to solve it in phasor. In phasor than in time domain. So that's really why we're doing the switching. And to switch from time to complex or phasor is not that difficult, and to switch back is not that difficult. You'll see that in a minute. So what happens when you have a resistor in time domain? So this is time domain, and I want to switch that to phasor or complex. What happens when you have a resistor of the value of R? When you switch it to phasor, that resistor stays the same value. But because we're dealing with complex value instead of R, we call it Z. So Z really is equal to the R value. That doesn't change. So if the resistor is 5 ohms, we'll say now has an impedance of 5 ohms. Z is really the impedance. When you have an inductor with the value of L in time domain, when you switch it to phasor, that has a value called ZL equals J omega L. Omega is the frequency. What's omega? Omega equals 2 pi F. In the USA, we use a frequency of what? 60 hertz, right? So if you do the math, it's 2 pi times 60, and you end up with 377. So a lot of times when you look in our book, you see a sine wave, your source, a sine, like 120 cosine 377 t. Go, what's the 377? That's what that number is, 2 pi f. If you're in Europe, Europe uses what for frequency? 50. That'll be 314, you know. And again, if you're using actually, this is in rectangular mode, we use J, but if you use phasor, this is what? Remember, your axes here, I'm just trying to put everything on the same line. When we did complex numbers last class, we said this is the real portion, This is the imaginary. So since that's a j here, your vector is pointing upward. So if you want to change it to a phasor that has a value of wn.
Hey Google, why are imaginary numbers named that way?
On the website mathsisfun.com, they say, imaginary numbers were once thought to be impossible, and so they were called imaginary. People also sometimes ask me, where did imaginary numbers get their name? Do you want to hear the answer?
Yes.
On the website toronto.edu, they say, the name dates back to when they were first introduced, before their existence was really understood. At that point in time, people were imagining what it would be like to have a number system that contained square roots of negative numbers, hence the name, imaginary.
Very interesting.
Because the square root of that, when you square it's the same thing. And the angle is 90 degrees.
Hey Google, what does Z stand for in circuits?
On the website electronicsclub.info, they say, impedance. Impedance is a measure of the overall opposition of a circuit to current, in other words, how much the circuit impedes the flow of charge.
Hey Google, what's the difference between impedance and inductance?
On the website circuitglobe.com, they say, the opposition offered to the flow of current in an AC circuit because of resistance, capacitance and inductance is known as impedance. Resistance occurs in both AC and DC circuit, whereas impedance takes place only in an AC circuit.
By the time I finish my degree, I could probably be a loudspeaker engineer. A real one, not a recording engineer. Oh, I'm still streaming.
You're in the positive j direction, going upward. And if you have a capacitor, C, the value of that capacitor when you go to phasor, it's 1 over j omega c. Remember, j is the square root of minus 1. If you multiply the top and the bottom by j, you end up with j over j squared. Well, j squared is minus 1. So a lot of times we write that negative j over omega c.
That does not look like omega.
And again, if you want to convert that to phasor, it is 1 over omega c, that's the value. And the negative j, what angle? You can see that plus 270 or negative 90 degrees. It's the same thing. Negative 90 or positive 270. And what about the source? So we know how to convert the resistor, we know how to convert the inductor, we know how to convert the capacitor. What about the source? How do we convert the source from time domain to phasor? If you have a source of 50 cosine Wt plus, I always run out of space. I'll move it. Let's say you have that source. Well, let's call it, instead of a number, let's just use a variable here. We'll call some maximum value. Vmax, because that's the voltage source, some maximum number cosine Wt. When you switch it to phasor now, this source will be still the same source, but the value in phasor we write that Vm, notice, and angle phi. So if I have a source now, and I'll put this aside, if I have a voltage source of 20 cosine Wt, let's say plus 30 degrees. When I switch that to phasor, that'll be what? 20 angle what? 30 degrees. What about if your source is a sine function? What is the difference between a sine and a cosine? Shifted by how many degrees? 90 degrees, forward or backward. So if you have a source, let's say current source instead of voltage, we'll just change it, of a value I sub m sine Wt. That's a sine. I don't know if you can see the I there. First, I can convert that to a cosine. Wt. And the question I'm asking, it's 90 degrees, but I'm not sure if it's positive or negative. I forgot. We'll pick an angle, like 30 degrees, right? Let's say 30 degrees. So if you make Wt 30 degrees here, all of Wt is 30 degrees. What's sine of 30? 0.5? Right? Now, if Wt is 30, let's say it's sine, I'm thinking as a plus. If I make it a plus, what's 30 plus 90? 120, right?
120.
Now remember, all students take calculus. Anyone knows what that means?
Where
The trig functions are positive, correct, yep. So the sine is positive, the cosine is positive, the tangent is positive. Here only the sine is positive, student begins with S here. Cosine is negative, the tangent is negative. Here the tangent is positive, which means the sine is negative, cosine is negative, tangent is positive. And in this quadrant, what? Sine is positive, cosine is positive. Oh, sine is negative, cosine is positive. Only the C, the cosine, is positive. That's a negative. And the tangent is negative. So if I let Wt be 30, the sine in the first quadrant is positive. So if I make this addition here instead of subtraction, addition, what's 30 plus 190? 120, you're going to be in this quadrant. Is the cosine going to be positive or negative? You know it's not right then. But if I make it minus here, if it's 30 degrees, what's 30 minus 90? Negative 60 down here. Is the cosine positive or negative? Positive, it matches that one. So it is a subtraction of 90 degrees. So when you have a sine function, to change it to a phasor now, in phasor, what is that equal to? Well, before I get to phasor, this problem becomes cosine Wt minus 90. So in phasor, this will be what? I am angle negative 90 degrees. Oh, current source it was, right? It wasn't a voltage. I used a current here. I forgot.
I'm really confused about that.
I use a current source here.
So that's your V now?
That's in phasor, yep. That's the negative 90, correct. So if I have, for example, my source now, a number here, if I have a current source or a voltage source, doesn't really matter, 20 sine 377t plus 40 degrees. I need to convert that to a cosine. This will be 20 cosine 377t plus the 40. When you go from sine to cosine, you subtract 90 degrees. So when you do the math, this source becomes what? 20 cosine what? 377t minus the 50. And now let's change it to phasor. Here we go. We're going to switch that to a phasor. In phasor, we write that as what? 20 angle negative 50. You see what happened to the 377? If your source is cosine 377t, if you calculate the current going through every branch in that circuit, or the voltage, they're all going to have cosine 377. What we're trying to find out is the difference, that value there. So at the end, my answer is going to be, I'm going to bring that 377 back in, but it's going to be shifted by negative 50 degrees. So let me take an example, put all these pieces together, and see how that works. Let me take a basic function. I go to the end of the chapter, grab a problem there. Just straightforward, simple question for now. I can make one up, but too early for me to make things up. Okay, there we go. Some stupid numbers in this one, but that's okay. It's only an inductor. Let's even make it worse. Inductor, capacitor, everything. Let's put the entire, here we go. I have this problem. And I always regret when I draw the picture before I write the value. I always run out of space. 4 cosine 100t minus 100t minus 20, and I just realized I already drew it wrong. That's a current source. My eyes are bad. For those people watching me on YouTube.
Move it over a little bit.
That's a current source. I can shrink it. I can't shrink it really. 4 cosine 100t minus 20. It's a current source in parallel with
Okay, this is a stopping point. Complex numbers seemed pretty simple. I did get the information that polar and phasor are essentially the same thing, and you know, it's dealing with angle degrees. I don't know, I'm just having a hard time with like focusing. It's probably my damn ADD. So yeah, I'm pausing. It's 2 o'clock. I'm going to upload this Twitch stream VOD to my YouTube live channel, and below on this Twitch page there should be like donations, so please donate. I don't have the overlays anymore right now for for my financial goal, yeah, I could definitely use some extra cash. I got a lot to do. Definitely going through a bit of a rough patch in life, but I always land on my feet. I'm fucking resilient. And I might do another stream tonight. Maybe I'll set up some kind of schedule. It's kind of hard to tell. You know, this was an example of me talking about my setup and just like watching YouTube videos, part of the learning. These are the notes that I've taken. So maybe I could set up 2 cameras. I don't know if that would work simultaneously. That would be pretty freaking cool. Actually, I'll make a note. Oh, where are you, pencil? Come on. I was really enjoying that pencil. How does the pencil just disappear? That's annoying. Okay, so look below to donate to my Twitch stream because I'm a student. I could use some cash. I'm probably also going to link some like Bitcoin donation. I've been into Bitcoin since 2017. What else do we want? Subscribe to my YouTube live stream channel, subscribe to my main channel, and please tell all of your friends and their mothers about my YouTube channel and my Twitch channels. Sorry, my Twitch channel and my YouTube channels. Actually, I mean, more so the YouTube ones. I don't really care about Twitch too much. I just like that they don't restrict me from streaming like YouTube does. It's annoying. And yeah, I don't know. Leave me comments about the kind of videos you'd like me to stream. I'm definitely going to be doing a lot of homework stuff, so some of it's going to be these YouTube videos and me talking through like my notes, and how I study, and then others will be me using my circuit simulation software. And then I was thinking of doing some like entertainment ones where I talk about my favorite YouTube channels. And thinking about reading some news articles. So yeah, I'll probably do that as like a Twitch stream and then upload it to my live. Because that's just going to be a lot of like random content, and maybe on the main channel I'll do like a month of tech news review, so it doesn't get oversaturated. Okay, so stop streaming for now.